In this video, we're going to be talking about critical numbers for a particular function. What are they and how do we find them? Because in the upcoming videos, again, we're going to kind of put that knowledge together with our knowledge of increasing and decreasing functions to get to this first derivative test that helps us determine what are called local extrema. So all of this is sort of building towards something, but we need these key components first. So critical numbers, the definition of a critical number says, if f is a function, then a number c, we're going to call that number c, for which f of c is defined. So in other words, the function actually has to exist at c. So we have a number c for which f of c is defined, and either f prime of c equals 0 or f prime of c does not exist, then c is called a critical number of f. So in order for a number to be a critical number of a function, the derivative of the function at that number has to be 0, or, whoops, I just realized I have a mistake on here. That should say f prime of c does not exist. So if either the derivative at that point c is 0 or the derivative at that point c does not exist, then c is a critical number. And sometimes you'll hear people also talk about critical point. And that's when, instead of just looking at the number itself, we write the point in ordered pair form. So the x value would be c, and the y value would be whatever we get when we put c into the function. Which, by the way, that's why it has to be defined, is because if we were to write it as a critical point, it needs to have a y value associated with it. Okay, so that's the idea with critical numbers. Now, let's take a look at how to find these. So let's say, as an example, let's say I wanted to find the critical numbers of and let's say we have f of x is equal to x cubed plus 3x squared minus 9x plus 4. And we want to find our critical numbers. Well, according to the definition, to find critical numbers, we need to know something about the derivative of the function. Because again, the defining feature of a critical number is that either the derivative of the function at that number is 0, or the derivative of the function at that number does not exist. But both of those require me to know what the derivative of the function is. So our first step is actually to find f prime of x. Okay, so to find our derivative here, the derivative of x cubed, we bring that 3 down front and subtract 1 from the exponent. So we have a 3x squared. The derivative of the second term, 3x squared, we bring the 2 down front and it becomes a multiplier. So 2 times 3 is 6. X, subtract 1 from the exponent, it just becomes a 1. so that's the same thing as x. The derivative of minus 9x, we have minus 9. And then the derivative of positive 4, because it's a constant, is equal to 0. And then because our definition of critical numbers said that we're looking for a place where the derivative of the function is equal to 0, we're actually going to set the derivative equal to 0 and solve for x. You'll notice each of these terms has a factor of 3, right? They're all evenly divisible by 3. So I'm actually going to divide that 3 out just to make my factoring easier. So that makes this left-hand side x squared plus 2x minus 3 is equal to 0. If the left-hand side didn't factor, you could, of course, use the quadratic formula. But in this case, it does factor quite nicely into x plus 3 and x minus 1. And then solving for x, we get negative 3. And we also get positive 1. And these are our critical numbers for that function. You'll notice that we don't have a case where we get a critical number because the derivative does not exist, because since this is a quadratic, quadratics exist everywhere. Any value that we put in for x, we're going to get a value out for y. So we don't have any critical numbers that arise from that second case here where f prime does not exist. We only have the critical numbers negative 3 and 1 because those are the ones that cause the derivative to be equal to 0.